all of the body biology is based upon pulsatility. When the heart beats, it sends out not just blood volume, but a pressure wave. So the volume of blood gets into the aorta expands because it's elastic, and then the aortic valve closes, so the heart's not beating anymore. Then the aorta goes back to its normal elastic shape, and that has a further effect of propagating this wave all the way down to your feet and to the furthest, most distal vascular beds. And you can't help but believe that that's got to give you a better perfusion than no pulsatility at all. Basically what we have in cardiopulmonary support when we do open heart operations is a continuous flow roller pump. Essentially the idea that Michael DeBakey came up with 50 years ago. So we're able to do essentially a whole variety of open heart operations while the patient is being supported with a heart-lung machine. Now, that's the good part. The bad part is that we've learned some of the limitations of this technology over the years, and we know that the longer the patient is on this kind of support, the higher the mortality rate. And some of that's related to the patient being particularly sick or complicated, but some of it's just related to being supported. And the blood takes a beating, and the patient takes a beating, and eventually the patient gets very sick, and multiple organs fail, and mortality rates are very high. Continuous flow is just, it's flow without pulsation. So there is no stroke volume, there is no propagation of a pressure wave, there is no augmentation of the pressure as it goes down the vascular bed. The sort of slingshot effect you get from pulsatility from the big vessels, vessels like the aorta and its major branches. Not only do they go away when you're on continuous flow, but there's damage to those vessels. There's a continuous stretching that causes dropout of important cells that are stimulated by the pulsatility. If you don't have pulsatility, these cells stop doing the thing they're supposed to do. They're dilator substances that they make. And so you tend to get a constriction of the vascular bed. That drives pressures higher with the same flow. That may in fact be the reason people get GI bleeding and strokes with continuous flow mechanical circulatory support. But further, it may be why people go into shock after cardiopulmonary bypass when it goes on for more than 3 or 4 hours. So, you know, there's a lot that's not understood, but we do understand that continuous flow has problems. Pulsatile flow seems to be better because that's what we all have, and that's what goes on for essentially our lifetimes and has gone on for millions of years in all of the evolutionary chain that has led to humans that have only been around for 250 million years. But I mean, it goes way back a billion years almost to pulsatile hearts. So I think it's a proven product, whereas we've stumbled onto this thing 50 years ago with heart-lung machines, and just a few years ago with mechanical circulatory support. And I know we're enthusiastic, and I know the results are looking good on the short term in some cases, but we're also seeing some red lights going off. And that's why I think we ought to re-examine this whole question of pulsatility. The other interesting thing, if you dig deep a little bit behind the scenes with mechanical circulatory support, is that every device company that has continuous flow is trying to turn their device into a pulsatile device. Now, why are they doing that? They're not going to advertise why they're doing it. They're not going to make it public. They're not going to cause alarm in the minds of the cardiologists and the cardiac surgeons. But in fact, the reason they're doing it is they can see these shortcomings that I'm mentioning, and they want the next generation to have pulsatility, because they figure within 2 or 3 years, it's going to dawn on everybody that we're having major trouble with continuous flow. True pulse is something that's indistinguishable from the pulse wave that's produced by the human heart. A volume displacement pump, one that has a membrane that pushes back and forth, can deliver a pulsation that is virtually identical to what comes out of the heart. The spinning pumps are never going to make a volume displacement type of pressure curve. I mean, if you accelerate and decelerate a roller pump, you're going to create a fair amount of damage just in the acceleration and deceleration. But if you have just a big old membrane that's going back and forth, that hardly causes any disturbance on the surface, you know, the stress and strain on the surface that affects platelet activation and clotting proteins and so forth. It hardly causes any. So I think it's not only is it good, but I think it's probably preferable to any other technology that is out there at the present time. VentriFlo is the only thing out there right now that I'm aware of that really produces a physiologic pulse pressure. VentriFlo is completely capable of producing a true pulse that's indistinguishable from the pulse that the heart creates. I think it could become the standard of care. I really honestly do. You know, I think that it might be so much better than continuous flow. It might convince the skeptics that are doing the off-pump bypasses now to come back into the fold, because the damage to the patient would be minimized. Patients would do better. They'd go home earlier. They'd have less complications and so forth. So I think it's a paradigm changing idea, and if we can just develop some evidence for it, I think it could change the way that all cardiac surgeons and cardiologists look at what they're doing today. And that's a very powerful idea. I mean, there aren't too many ideas like that out there that really can make an about face happen, but I think pulsatile flow might be one. It is going to change the way we do cardiopulmonary bypass in a way that makes it easier and safer for the patient. And that will have a whole series of repercussions in the way we do things, and the way we care for things, and the way things are financed, and the way we look at our attitudes about how we approach a whole host of problems in the field. So I think it's that kind of an idea that could really make things so much better that we would be forced to use it because it would be better. I think VentriFlo is blood flow the way it should be. I really do.